Hello, it's Keith here, and this is lesson 6 of the platform-specific series of my 6809 assembly programming tutorials. And today we're going to be looking at drawing graphics on the Vectrex, of course in vectors, because everything is. Now, unlike most of the systems I cover, today I'm going to have to give you a bit of a warning that I don't really think I've fully got to grips with the Vectrex. The reason for this is that I'm covering an awful lot of systems these days. I'm covering over 30 systems on about 6 CPUs, and I simply don't have the time to become an expert on these systems. So while the tutorials I'm going to show you today are of course available for download and seem to work as presented, I can't tell you that I've fully got to grips with this system because I'm afraid I don't think I have. Now, what I'd recommend you do is if you go to my website, there's a link to some Vectrex tutorial documents. These are sort of manuals that I believe are actually official documentation, and these are what I've based this tutorial on, but I didn't quite get a full understanding of things like the positioning commands that I'm using in this lesson. So I'd suggest you have a look at them yourself and maybe you'll come to different conclusions to me. Now, we're going to be going through these examples, and as I say, they all give good demonstrations of the simple commands. All these commands are being done with the firmware because, as I've said before, the Vectrex is very different to the other systems, and it's not really possible for me to go straight to the hardware, at least within the time that I have to write these tutorials. So those are some limitations that I'm afraid are the case with today's examples. There's just nothing I can do within the time constraints, as this is such a complicated system from the way it works, and it's just so different to all of the other systems that I cover. Okay, with that disclaimer out the way then, let's go over to today's source code and let's see what we've got. So as always, we've got a nice example here today. We're going to be looking at it. Let's go over the code. Now, as before, the Vectrex has to sort of redraw its screen every single frame. That's the way it works. So we've got an infinite loop here. We're going to be running a subroutine that's going to do one of these little tests here. And then what we're doing is we're waiting for the frame to start redrawing here, and then we're going to have to reset things up every time. Now, what we're doing here is we're setting a setting called Z-skip here, and we're setting this to 0 here, and that will set to relative positioning, and that's what these tutorials are all assuming. Now, the way the Vectrex works is typically you will draw something, and then you will move the sort of drawing dot, if you will, by an offset from the last draw, and you will set a new draw, and then you will set another offset. And some of the commands are absolute, so a value of 0 would be the center, and some are relative, so a value of 0 will be no move from the last draw. Now, just to make things consistent, I'm setting Z-skip to 0 here, and that will mean that everything is going to be relative. We do, however, have a command I've written called reset pen pos, which I'm hoping will zero the pen position back to the center. I say hoping because I had some unpredictable results, shall we say. There's multiple commands to reset the pen position, and this is part of the reason that I've had to sort of say I'm no expert on this system, because I've written what seems to work. I don't necessarily understand exactly why it works in some cases, unfortunately. I will explain in a moment. So that's what we're doing there. We have to set the direct page to D0, which is the hardware registers. That's something we have to do here. And then that will hopefully you do all of our drawing okay. We're also setting a default font size here just for consistency. Now, if you want to use my debugging tools, you will need to turn on the monitor, and so you can use these commands here instead if you want to use the monitor. And just disable this one, and if we run now, you can see our first example, and we've got the monitor. So if you need to see things on screen, you want to use those. If you don't need to see things on screen, just use the example itself like that. And as I say, we're going to discuss what this example is doing in just a moment. Okay, let's have a look at this reset pen pos command then. Now, this is what I'm using all over the place to reset everything back to 0, because as I say, the vast majority of the commands are relative to the last drawing position, and we'll see what that means in a moment with the dot drawing. Now, if we want to 0 things, I found I had to use a pair of commands to be most reliable. There seem to be some cases where just one command didn't work. Now, the internal hardware of the Vectrex has something known as the integrators, and these move the beam around the CRT. And if we run F3 this will 0 the integrators. Now, logically speaking, that sounded like it should reset everything, but it didn't seem to in my testing. So I then started using another routine as well, known as posit B, which would actually move to a position specified, and we specify the position strangely with a 2-byte pointer. So we point to 2 bytes and we're pointing to 0, 0, which means center. We also set the scale, which is quite handy. 127 is normal scale, 64 will be half scale, and 255 will be double scale, and that's quite handy, and we'll learn why in a moment. So, as I say, in my testing, I needed both of these, and I think this will always reset everything. But as I say, I'm afraid I don't feel I have the full grips of this system yet. I've just got the best I could get within the time I had to write this tutorial, and I'm not sure at this stage whether I will continue writing anything more with the Vectrex games-wise, because it's such a complicated system and it takes so much. It's so different to the other systems I cover. It takes a lot of time. Okay, anyway, this is what we've got today. So that will hopefully reset everything for the next test, and this means we can run consecutive tests all on the same screen, and they should work consistently. Now, what's our first test? Well, the first test is draw dots. So we're going to draw just a single dot on the screen. Now, we've got this command here, .ab here, and this will draw a relative dot here. So we're drawing a dot with F2C3. Now, the X and Y position is 16, 16, and we're drawing a dot. We're then setting an offset of 16, 16 again, because these are relative, you see. So this will be relative to 0, 0, and this will be relative to the last dot here. Now, we've done these 2 dots, and if I just run here, you can see them here and here. Now, the 0 is, well, you can see it's just there. So you can see each one is the same sized offset from the last one in the center. So that's our relative positioning. Now, if we want to reset back to the center, we can use this reset pen pos function I wrote, and that will hopefully do it for us. That's what we're doing here. And then we're drawing 2 dots here, and this time the X position and the Y position are being set to 0 for each dot. And then we're using this value here, and this is just a test value I've made that is auto incrementing from 0 to 255. So we can see what different values will do to a particular parameter, in this case the X and Y position. Now, if I run this here, you'll see these are going across the screen, and the dot along the x-axis looks like it's reaching the absolute edge of the screen here, but the y dot is going all the way up here, and it gets to about here and then it disappears. It's not reaching the top of the screen, and that's because of the scale. The scale is too low. Now, we can fix that though if we go back down to our command here. We were setting the scale here. If we now set the scale to 255, everything will effectively double. You can see the dots now are much further apart, and the dot and this moving dots are now filling the entire range of the screen, and are actually disappearing for some time because they've actually gone off the screen. So we can, if we need to, cover a larger range by increasing the scale. Now, the scale will of course affect everything, but we can change the scale for individual commands if we need. So the dots could be drawn at one scale, and then later examples could be drawn at other scales if we require. So that's a way we can get around the 1 byte limitation on the positioning. Now, that's the dots. Let's have a look at lines. So here's our second example here. We're going to draw some lines. Now, first of all, we're going to draw a line that's 127 by 127 in length here. We're doing this with diff AB. This is a relative command here. This is function F3df. Then we're going to reset the pen position, and now what we're going to do is we're going to move the pen position to a new location, and we're going to move the pen position with posit n here, F312, and we're going to move to basically minus 17, minus 117 here, and then we're going to draw another line, and we're going to draw a line that is plus 16, there's a good old typo there, in height, and then minus 17 in length, so it's going to go that direction. Now, let's just fire this up and we'll see what happens. Well, the 0 position is here. So first of all, we've drawn this long line here, and then we've moved the pen position down to here, and we've drawn this short line here. Now, if I just remove this extra moving of the pen here and I run again, well, now you can see that the 2 lines are joined together here, and so that's where the 0 position was. If I change the values here to 10 and F0 here, well, now you can see we've moved the pen position up and left. So we can move the pen position around, and we can draw lines in any one of these directions here. So that's how we can draw lines at positions of our requirement. And as I said before, if we need to reset the pen position, we can use this command here. Of course, we can also position using this function here as well if we prefer. So that's how we can draw dots and lines. Now hopefully all of these tutorial examples should be able to run consecutively, because everything is being reset after each one now. The two dots are actually overlapping that line, so we can't see them there, but you can see these dots are moving across the screen, and again they're still hitting the 0 position because we're resetting the pen position after each draw. Okay, so that's how we can draw dots and lines. Next we're going to look at drawing strings. Now the Hello World example, we drew a string sequence, a list of strings, because that's the easiest way of getting a lot of text onto the screen. However, if we just want to draw a single piece of text, we can use the position and draw raster message function at EAA8 here. And if we just run this here, we're going to show a Hello World message, and it can only be uppercase because that's the raster font of the Vectrex, and it just needs to be terminated with hexadecimal 80 here. And here we've drawn two hello worlds at absolute positions at 10, 10 in hexadecimal and 15, 15 here, so you can see them there. Now of course we could also do these in negative positions. If we do F5, F5 here, this will now be a negative position, so the starting drawing position is now to the left here and down, so it's just over here. And you can see we can draw whatever text we want really. So this is quite a handy way of drawing text to the screen. It's a little bit simpler than the last one. As I say, the last one we used to do a list that was 0 terminated, and that's good for getting a lot of text onto the screen, but it's not so good for just a single message if you just need a simple thing. Now, as before, we can actually change the font with this function size ras here, C8 to A here. And depending on the settings we use here, we will get different font sizes, and the ones I'd suggest you try are FC38 or F848. You can use other things though. So if we change to this alternate one, well, now our text is very big indeed. If that's what you need, then that will be great for you. I use the smaller one because it allows more text on the screen and it looks good with the monitor function. So that's why I use that smaller text, but you know, whatever you need for your game, of course. Okay, so that's how we can draw dots, lines and text, but of course we're going to, at some point, we're going to want to draw some graphics. Like for example, we might want to draw a Chibico character to the screen. Look at that Chibico character there. So how can we do this? Well, the Vectrex has some formats of its own, and you can see as it gets too big it starts flickering, because of course the Vectrex is requiring the beam to draw every single frame before the phosphors fade. So if we draw too much, it starts getting slow. So we can define a graphic, and there are three formats that we can use to do this. These are known as Duffy, Diffie and Packet. Now why are they known as that? I don't know. That's the simple answer to that. Now the packet one is the most advanced. Duffy and Diffie are almost exactly the same. Now with a Diffie list, there is a sequence of moves, all of which are connected lines. So they're relative moves compared to the last position. So 0, 0 would do nothing and would just waste a byte basically. But if you did a 10, 10, 10, 10, 10, 10, 10, you would draw in the end a straight line. So these are drawing a little picture. This isn't the Chibico character. The Chibico character is enormous, and that's too complicated. That's a packet list. This is the Chibico character. It's too complicated for what we're discussing here. The Diffie list starts from the last position that the pen was drawing at. The Duffy list is slightly different. It will start from an initial move to a position that's specified. In this case, we're just specifying 0, 0, but that means just keep the pen at the current position. So the Diffie and Duffy are almost identical. They have y, x coordinates in a list. All of them are connected lines. The only difference is the Duffy has an initial move to a start position if we want to do that. So that's the difference between Duffy and Diffie. Packet is more advanced. You see, Duffy and Diffie can only draw a sequence of connected lines, so like a circle, or what I do is an exclamation mark, so kind of like that. Sort of, you'll see in a second. It's sort of an exclamation mark, but Packet is much more advanced. You can draw a circle, lift the pen up, move to a new position, draw another circle, and that's the kind of thing we need for our Chibico character. So the way the Packet works is we have a YX sequence, but we have an extra byte, and that is 0 if the pen is up, i.e. we're moving the pen, and FF if the pen is down, meaning we're drawing lines in a sequence, and then 0, 1 means end of list. So that's our packet. Now these three are all the same graphic in just the different formats. So if you look at the y-x coordinates here, they're the same as the y-x coordinates here and here. So this is designed to allow you to see the difference between the three kinds of list. So that's what we're going to do next. We're going to draw these lists. So if we just fire this up here, we will see these three lists, and here they are. So we've drawn this exclamation mark a total of 4 times here, and we're using different commands to do this. So as I say, this is all connected lines. You can sort of see here there's no gap between any of the lines, whereas with our Chibico character there definitely was gaps, because there's things like the mouth which is not connected to the face. So not very easy to draw Chibico with these simple Diffie and Duffy lists, but possible with the packet, although the memory is huge. So that's the limitation of the packet, because of that, the extra byte per coordinate. Now we've looked at various options of drawing here, and first of all we've drawn with the Duffy AB list here, and we've used this command here. Now this is relative to the current position here, so we've set a starting position here, and then we've used the Duffy command here, F3AD. Now this will use a list with an item count at the start here, so the item count is 8 here, and then you can see that there's the list itself. So the list length is defined by the first byte. Now that's the first option we've used, but then we've used an alternate version, which is Duffy list with scale. So this is DuffX, and this is F3B5 here. And you can see here there's just 1 extra byte after the line count, and that's a scale, and we set the scale to half, and that's why the second exclamation mark was smaller than the first. And you'll notice the other commands never set a new scale, so they all ended up smaller. So yeah, that's an extra option for the Duffy list if we want. We've then used a Diffie list. You can see the Diffie list here. We don't have a scale on this one, so we've done that. We've drawn that with DiffAX, and that's F3CE. And then finally, we've drawn the most advanced one, the packet list. We specified our scale in B here. We specified the pointer to the packet list, of course. Now the packet list doesn't have an item count at the start. It has that 0, 1 at the end to define the count of items. So that's what we've done there. Now if we change this to 128, of course, 127, sorry, that is roughly 1 times scale. So now you can see our last exclamation mark is much bigger, and it looks a bit messy, but so that's an example of how we can draw an item in different ways depending on our requirements. And basically I think you're probably going to be best with either a Diffie or Duffy. There's not much difference for simple objects, you know, maybe your circular asteroid, but then for complex objects I think you're going to have to use a packet list, although the size is a problem, because you know, for those it doesn't look too bad, but when you see the enormous Chibico graphic, both enormous in scale and in byte size, unfortunately. If we just go down here and look at it all, well, you can see it's enormous, but you can kind of work out what's going on here, and it looks like there's actually a bug here, because those two are 2 consecutive moves of the pen. We could combine those together with some mathematics and fix those. Now, how did I make the graphic? Well, there is some very crude functionality in Acrosprite editor for drawing vectors. It's not really good enough, to be honest. It's an experimental function, but basically if we go here and we can draw a object here if we wish, that's with the left mouse, and then if I press right mouse we can move to a new position. Oh, I did that wrong. We can kind of draw a smiley face there, and we can transfer that to the clipboard here, and we can select the options here. It can support packet or Duffy. Now packet is a custom format of my own that I used on some Z80, so that's not a Vectrex format, but you can convert the Duffy to the Diffie just by removing the first line, of course. So it's got very crude functionality here, but it's not really of the standard of the other functionality. It was just something quick I knocked together for this tutorial. So anyway, that's how we can draw more complex graphics with the Vectrex. Now finally, the last thing we're going to look at here is rotation. Now we can actually scale objects, as you saw, just by changing the settings, either using our location command, either using a command like that, or by putting it at the first line of that Diffie list. But if we want to rotate, it's unfortunately more tricky. We can't do that automatically, if you will, but just by specifying a parameter somewhere, we actually need to use a command which will rotate the data in memory. So this time we're going to draw a smiley face and we're going to make it rotate. Let's see it there. So there we go, we've got a smiley face and it's rotating around. Now, how do we do this? Well, what we've done is we've defined a packet list, which is a smile here. That's the smiley. We have to use the function f61f, which will rotate a packet list and it will store the destination in memory. So what we're doing here is we're specifying the rotation angle, and I'm using that automatically changing value in memory address C9FF here. We're specifying a source packet list, packet smile, a destination, which is memory C880, and then we're calling f61f, which will perform the rotation for us. And then we're drawing that rotated packet list to the screen, which is of course at memory address C880 here, and we just drew using the draw packet function as before, and we're specifying the scale there of course. So this allows us to do the rotation, but unfortunately we have to do it as an extra stage, and we do have to use memory. Now if I want to be a bit funny, I could maybe specify the scale to change as well, and so now it will rotate and zoom at the same time. So there we go. I don't know if that's something we want, but we can certainly do that. But anyway, as I say, we can do the rotation, but unfortunately we do have to use some memory. And memory is a little bit precious on the old Vectrex, so it's far from ideal. But anyway, in this tutorial we've now seen how we can draw graphics, we can rotate them, we can scale them, we can draw lines, dots and text. And we looked at before how we could actually read in the joysticks and things. So maybe we've now got enough to make a simple game. Anyway, that's all we're going to be covering today. Unfortunately, I'm afraid that's about the limit of what I can cover at the moment because of my skill level. We're still going to come back and do sound though, because the Vectrex uses the AY sound chip, the same as the Amstrad CPC, so that's something I do know about. So we're going to be looking at that as well. If you've liked this tutorial, please like and subscribe. I'm going to do more Vectrex with those AY tutorials, and just generally going forwards. Ideally, I would like to do a lot more 6809 work, but time is very limited, so I'm going to have to make my judgments on how to spend my time based on viewer interest and things. So if you do like what you see, please like and subscribe. And if you're really enthusiastic, you can always back me on Patreon, because I do prioritize my work schedule based on what the patrons are interested in first and foremost, because obviously they're paying me to do so. So if you're really interested, that's an option for you. Anyway, I hope you've enjoyed this. Thanks for watching today, and goodbye.